Hello, everyone. I hope everyone had a nice week and everyone is doing well with the lessons and doing well with the assignments. If you do have questions about assignments or any video lessons, feel free to leave a comment in the YouTube, or you're welcome to leave a comment in Google Classroom so that we can discuss about them. Also, feel free to bring the questions when we meet up next time, which will be the end of February. Okay? So today, what we're going to be talking about is we'll be talking about, oops, inputs and outputs. And after that, we'll talk a little bit about code challenge we're going to do with traffic light. Inputs and outputs. So as you can see here, we have input here, output here, and of course, in between there has to be something, okay? We call it process. Sometimes we call it function. But the point here is that when you input something and there's output, if there's no process in between, what you're gonna end up with is you're gonna end up with same input as your output. So they will be the same because why? Nothing has changed. So depending on what you wanted to set your process properly, accordingly. So the reason why this is important is because even though the concept of input and output, everyone knows about it, but we want to emphasize how important this is because you really need to be aware and know what you're dealing with. What is the problem? What are you given with, and what do you want? And knowing this allows you to design and make your process part. Okay. So let's go a little deeper with input and output. All right. So here we go. Input, by definition, is signals or data received by the system. Well, it doesn't really have to be signal or data. It can be anything. Okay. It can be an object. It can be multiple objects. It can be multiple signals. It can be anything, but whatever it is, it's received by the system. And output, just like input, is signals and data sent from the system. It doesn't have to be signal or data. It can be an object. It can be multiple objects, but it can be also a combination of multiple things, right? So input and output. So you can see on the right, you have a GIF file, and you have food incoming in. So in this case, food will be your input, right? And the output will be, well, you might be thinking it's the feces, right? Or the poop. But not only that, we get energy out of it. So energy is also part of the output, and also nutrients will be also part of output. And what will be the process? Well, process, there are multiple things because as you can see here, this is a human digestive system, and all of this are part of what? Process. And how does this, well, that's processing device. So what is the actual process? It's in our brain, okay? Our DNA contains all the instructions of how to deal with a situation where people eat, and it triggers series of signals to your brain, and the brain tells all this digestive tract what to do. Okay, so that is the process, and that part is what we are concerned about in coding. But of course, remember what is being input is very important also, and what is being output is also important because why? That's the whole purpose of processing, right? Taking input so that we get out what we want. Okay. So example one, can you think of any input output devices in our body? Well, pause the video and think about a few things. Right. Hi, welcome back. So pretty much all human body systems that you learn in biology, they're all input and output systems. Okay. The reason why we have so many input output system is because to maintain something called homeostasis. Just in case you don't know, you should look it up. But since this is not biology class, we're not going to go deep with this. But the point here is, if you think about it, every day you're interacting, your body's doing something, that means there has been some sort of input in our body and we are reacting to it, right? Because we want to keep ourselves safe. And that's what body does. So our brain, our DNA contains all these instructions, okay? So it's a very complicated, complex coding in our body. Anyway, moving on. So let's do more, I guess, more tangible, more relatable, even though our body is also relatable. Let's do some computer equipments. So from here, let's identify which device might be input or output device. Pause the video and come back when you're done. All right, so hopefully you did something like this. So blue one is input device and red one is output device. So for example, keyboard. You can see on keyboard it's blue because why? What keyboard does is it's a device that takes our input. So if I want to say hi, I write hi, and the keyboard is the way of getting that information from us. So that's the input device. And for example, monitor will be output device because when I write hi, I can see, or the computer processes it, and then it shows me that I have typed hi on the screen. Some of the devices will be both. For example, interactive whiteboard. It can not only input, we can also get what we wrote. So that will be an example of multiple things. Your iPhone, your Android, all those smartphones, they both contains what they contain both input and output in the same source. So whenever you interact with something, it's good to think about, hey, what is input and what is output, and what might be processing in between so that the input becomes output. And this concept is not only in math, also you can find it in science, also pretty much everyday life. Okay, think about them. So if you have your kid, it's good to go over your devices. And these are some examples of input devices that you should have in your make kit if you had bought it. This one, Arduino. Arduino, I'm sorry. All right. Anyway, so if you read the names of them, right, you can pretty much guess what they do, right? But what these devices do usually mimics what we can do. For example, with our eyes, you know what? Actually, think about this. How many senses do we have? We have 5 senses, right? So all these senses, right? For example, sight, it gets information from light, right? And number 2, what is it? Tactile, your touching skill, touching a sense. And number 3, we have taste, right? And we have what? What else do we have? I forgot. Smell, right? Smell. And what else do we have? We have hearing. Yes, it took me some time, but we have hearing. So anyway, so we have devices that can mimic our sensor systems. So for example, here, illumination, and here, infrared. So you might think, hey, aren't they both light? Well, if you think about light, there are multiple things about light. For example, colors is a feature of light, and also illumination or brightness. So that might be also different parts of light. So even with light, there are multiple aspects of light that we can get. And also with light, you can also get distance, right? Because we can measure distance from our eyesight. So all these devices are input devices that can measure those metrics. Okay, moving on. Output devices. So like input devices, there are output devices where it can generate light. Well, we cannot generate light in a way, even though there's infrared. Motion, our muscle can do motion, but we have motors that can do it. Sound, well, there's a buzzer that making sound, and so on. So the output devices and input devices, it tries to mimic us, but except it can be better than us in a way, right? But anyway, moving on to next. All right, so if you see this diagram with input, output, and there's process, and we're gonna focus on process, okay? Because I think we talked enough about input and outputs. So process by definition is this. A process is basically what is happening in the system, and that will be covered by the coding, okay? So we're gonna have input, and our code will process that input so that we get what we want as an output. Right? So for example, so I'm not going to go deep with this, but our body has something called thermal regulation. So basically what it does is our body detects temperature because we have temperature sensors in our body. And what it does is it tries to maintain core temperature as stable as possible. Okay, that's what our body does. There are multiple ways to do it. One way is shivering. So when temperature gets cold, our bodies shiver because why? That vibration of muscle generates heat. Okay, so using that logic or knowledge, what we're going to do is we're going to help our friend Patrick. So let's say Patrick is outside, it's really cold, even though it's in the ocean, there's snow. but let's say it's happening, okay? So let's help our friend Patrick by coding how our skeletal muscles should behave depending on outside temperature. Now, hint, use if statement that we learned from last time. So just to going over, remember our input is temperature from temperature sensor in our body, and our output is the action of muscle. So pause the video and try to think of an answer and come back when you're done. Welcome back. So one solution is this. So basically, whenever you're given with a problem, just restate what's given to you and what's output and think about what your process needs to do. So as you can see, I wrote out a little sentence here. So we want our body to detect temperature. That's input, right? So our temperature receptor, it detects temperature. And what do we do with it? So we say, hey, if the temperature is low, so for example, 45 Fahrenheit, it's not exactly, everyone has different temperature threshold. We need to send signal to our muscle, okay? That's what our process needs to do, so that our output is vibration of our skeletal muscle. So in if-then statement will be, if temperature is less than 45 Fahrenheit, for example, it doesn't have to be 45, then activate our muscles. Very simple, right? And that code is in our brain, and that temperature changes depending on our situation, okay? That's why when you get sick, you shiver even though the temperature is not as low, okay? Because that changes depending on your situation. But anyway, moving on. All right, exercise 1. Cars nowadays come with an alarm system that alarms the driver when there's an object near the rear of the car. I'm sure you have seen it, heard it, because when you're driving backwards, sometimes it makes sound, bam, 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 because why? There's something near the rear. So your job is this. Think about what input and output devices you might be able to use from the Make Kit sensors. If you don't remember that, go back in the video or look it up in your Make Kit and come up with a list of what we can use. And also try to code what we can, try to code so that we can do this. Right? Pause the video and come back when you're done. All right, so this is one of the solutions you might have come up with. So of course you might have different answer. So as for your device, no matter what you chose, okay, there are multiple possibilities. Number one, you need to be able to somehow detect distance, right? So one example of finding distance is ultrasonic wave sensor. What it does is it sends out ultrasonic sound, and then it detects how fast it comes back. And by calculating the speed and the time, what it does is it calculates distance, okay? So this is one possibility. Another one was an infrared, because infrared is the same thing. It can detect the distance. An output device, maybe depending on what you want, I chose LED light because I want to make sure that the driver sees it, okay? The driver sees that it's alarming. And also I want the driver to hear it. So there are two ways to alert the driver, right? And code will be for something like this. So you get a distance from this sensor, and if the distance is maybe less than 3 feet, I mean the number is arbitrary number, it can be like 4 feet, then turn on yellow light or red light, doesn't matter, and turn on buzzer. So it makes sound and it blinks, so the driver knows. Otherwise, turn on green light. By the way, you don't really have to have this else statement, but I just did it so that driver knows that, oh, it's safe because it's green, all right? Moving on, this is exercise bonus. You don't have to do this, but read through this. It's very similar to thermoregulation we did, and here's the answer afterwards. Here we go. That's one of the possible answers, but you do not have to do that. It's a bonus, okay? Now, so let's talk about code challenge. So if you have not made your traffic light and you have the kit, please, if you need help, go through this PowerPoint slides, which you can find at the end of this lesson's PowerPoint slides, so that it helps you, it guides you to how to construct this traffic light if you haven't made yet, okay? And if you don't have this purchase, if you want to purchase, the description should be in the description of the video, so please refer to it. Otherwise, let's do code challenges. Code challenge number 1. Make green and red lights blink 5 times simultaneously with 1 second interval. So 1 second turn on, 1 second turn off, while yellow light is continuously on. Pause the video right now so you can try it on your own and come back when you're done. All right, let's talk about solution. Here we go. So remember, our green is 11, red is 10, and yellow is 9. So let's do so when we code, right, we usually do like part by part, okay? So what I want is I want to repeat something multiple times. So most likely we need some repetition, right? Repeating of 5 times, right? By the way, we're gonna put this in Arduino. Arduino is turned on instead of forever because we want to repeat this only 5 times. If you put this in forever, it repeats forever, right? So remember, we want to turn on our green light, which is 9, I believe, and we need to turn on red light 11, I believe, right? And let's check. Go back here and then play simulation. Oh, I messed up. Green is 11, red is 10. Totally fine, right? So there we go. So if you go back here, now you should see, hey, we have turned on our lights that we want, and then we're gonna wait 1 second, and after that, what we're gonna do is we're gonna turn them off, right? And let's see what happens. Okay, play. Do you see that it's blinking so fast? Do you know why? Because we didn't wait 1 second. Okay, let's wait 1 second here so that when it blinks, 1 second off, 1 second on, 1 second off, 1 second on, 1 second off, right? But what's wrong with this solution? We haven't done yellow light. So number 9, we need to turn on. So where should we put number 9? The beginning or inside of the loop or outside where? If you have said here, it's correct, right? Now, even if you put this inside this, it's still gonna work, but there we go. So yellow is still on and green and red are blinking. All right, let's talk about challenge number 2. In challenge number 2, it's like traffic light. So first time, green light for 3 seconds and changes to yellow light 2 seconds. But at the end, you want to blink the yellow light twice in 1 second, okay? Think about how that might work. And lastly, you want to turn on the red light for 2 seconds, and you want to repeat this forever. So think about how might this work and come back once you're done. Okay, welcome back. Hopefully you have thought about how to do this. And here's one possible solution. And here we go. It's pretty long, I'm sorry. And there we go. Now I'm not gonna go through all this, but I wanna show you that it works, okay? Let's go and simulate. 1, 2, 3, 1, 2, blink, blink, and go to red, 2, green, there we go. See, because I used repeat in between here, because I didn't wanna copy paste this twice. And then notice I used 0.5 seconds because if you divide 1 second into 4 parts, off, on, that's 0.5 seconds each. All right, moving on to part number 3. So your challenge is this: you have green, yellow, red light cycle in traffic light, right? But can you make it so that it skips a light every turn? So for example, if it was green, it skips yellow and goes to red. And if it's red, it skips green, goes to yellow. And let each light be 0.5 seconds on, 0.5 seconds off, so that you can see it pretty quick. When you're done, come back to check the solution. Before you code, let's come up with what this is, what is doing. So first one is green, right? And then after skipping yellow, it's going to be red, right? But after red, it's going to skip green, so we're going to get yellow, right? Once it's yellow, it's going to skip red and becomes green, and so on. So you can see that it's repeating, right? So instead of green, yellow, red, by giving this information, skipping turn, right, or skipping a light, it now became green, red, yellow, green, red, yellow. Okay, so the solution code is pretty simple. Let's go to solution code, and code is like this. Okay, very simple, right? So let's check this simulation: green, red, yellow, green, red, yellow, green, red, yellow, skipping a light. Do you see that? So that's it for the code challenge. I hope you had fun with it. And for your assignment, start reading through Streetlight project. So read through theories, all the background information, and even try to do it on your own as well, because it has really good instruction. Thank you, everyone. I hope you have a great week and see you next week. Bye-bye.